but really a lot of review stuff, hopefully nothing too crazy. And be happy, there's no find all 6 trig functions today, because that's obnoxious. Okay, evaluate the sine, cos, and tan. So we're just going to do the main 3. So here, of course, it seems like everything's always very repetitive this chapter. It's always the same thing. It's just a matter of the directions and how they give it to you. So I'm like, all right, well, 300 degrees. I don't know, maybe we should start by marking out a 300-degree angle. So mission 1. Now, you know I like to do my dramatic labeling, 0, 90, 180, and of course our full circle, 360. So, you know, just a review for the love of math, vertex on the origin, initial side. Nothing exciting here. Okay, 300 degrees is going to end up landing you in which quadrant? 4. All right, so let's mark it, 91, 82, 7, we're over here. I'm going to make my very dramatic label because you know I love it. I don't care if you do that part or not. Of course, you guys are awesome at this. We all know to make our right angle on the x-axis. And most importantly, what is your reference angle? How many degrees? 60. So we're on the 30, 60, 90. So we're going to label our sides. Opposite the 60, root 3. Opposite the 30, hypotenuse. Now, due to the location, do any of the sides need a negative on it? Because that's been a little dicey. The root 3 needs a negative because you're going down. So as always, be conscientious of the sign errors. I just saw a couple sign errors, kind of common sign errors, on our last quiz. All right, now it's easy. All right, they want sine, cos, and tan. Okay, fine, let's do it. So sine. So of course, opposite hypotenuse. Got it. Cos. Adjacent 1 hypotenuse. And let's do tan. I'm glad we don't have to do all 6 like yesterday. TOA, opposite, adjacent. So negative root 3 over 1. Let's just put negative root 3. So, as always, question of the day, have I taught you anything new? Nope, sure haven't. Okay, any questions on that guy? I have a feeling you're already starting on the next one. Ooh, fancy, radians. Fine, okay, let's convert it to degrees. Let's practice that. So what do you multiply by to convert to degrees? 180 over pi. Of course, our pi's cancel. I think do this one in my head, because 3 goes into 180 60 times. I need taller shoes so I can reach that. What's negative 4 times 60? Negative 240. You know the drill. Let's mark out our angle, make the right triangle, figure out our reference angle. Now, of course, the negative just means you're rotating clockwise or down. So I'm at negative 90, negative 180, negative 240 is going to be over here somewhere. Make your right angle on the x-axis. Okay, most important question. What's the reference angle? 60. Perfect. From 180 to 240, 60. I seem to like 60 today. Opposite the 60, root 3. Opposite the 31, hypotenuse 2. All right. Any of those sides need a negative? The 1, because you're going left. Okay, again, sine, cos, tan. Here we go. Let's mark them out. So sine, of course. Sine of negative 240. Just labeling all dramatic. Opposite hypotenuse. And then we need the cos of our angle, which we put it in the degrees. So cosine adjacent hypotenuse. And last but not least, tangent of our negative 240. What do you have for tangent? Negative square root of 30. Okay, so I'm not going to bore you. This is nothing new. You know how to do it. Obviously, don't forget some tips, think about your homework. If your angle is really, really large, what can you subtract to make your life easy? 360, you can make a coterminal angle. Remember the vocabulary for that if I give you something really big. But obviously, nothing crazy. All right, let's see what we got now. Find the indicated trig value. Ooh, happy day. I only need one answer. I only need one fraction, cosine, thank God. Okay. In the specified quadrant. Hey, they even tell me where to draw it. Quadrant 3. I'm all over it. Let's do it. Quadrant 3. 2, 3, here we are. Now, they give you the angle of theta, so I don't know, no special 30, 60, 45, any of that. They tell you tangent, so you have opposite and adjacent. So opposite, adjacent. Now, do either of those sides need negatives due to the locations? Yeah, both of them, left and down, which is perfect because 2 negatives, of course, make you that positive 3/2. Now, we need, final answer, cosine, which means cosine, I need hypotenuse in it. Okay, let's find the hypotenuse. So again, just a little Pythagorean theorem, nothing wild here. Most of you can probably just do this in your head. -2 squared, -3 squared. So I'm going to have 4, 9, what's 4 plus 9? 13. So the square root of 13. And that's kind of nice. 13's prime. I don't have to worry about simplifying. I know I asked you yesterday, but I'm going to ask you again today. Is the hypotenuse ever negative? No, because when you square out the numbers, they turn positive. All right, final answer. What is your fraction that represents cosine? I need the sides for cosine. So, of course, adjacent, -2. Hypotenuse, our very lovely root 13. And let's just do a little rationalizing, circle it up, and we'll be done. I like this. Only one answer, not all 6. They tell you where to draw it. Easy peasy. Any questions I can answer on that guy? I like that. I like that. An easy one. Hey, another easy one. Because they tell you specifically to draw it in quadrant 2. I don't even have to stress about it. I'm all about no stress. All right, quadrant 2. Here we go. And again, I don't know if we have any special angle measurements there. They're just using theta for the angle, so fine. You've got sine. So you have opposite, hypotenuse. And again, due to your location, hypotenuse always positive. The one's positive because you're going up. Now, I see we need secant. I'm like, okay, all right. So secant, of course, reciprocal of cosine. So I know I need that adjacent side. I already have the hypotenuse, but I'm going to find my adjacent side. So I'm going to do my Pythagorean theorem. 1 squared, a squared, hypotenuse 3 squared. All right, let's do a little mental math, of course. 1 squared 1, 3 squared 9. Let's take the 1 off of the 9, so we'll be down to 8 over here. Let's square root it. Now, that's not awful, but you can simplify it. What's the simplified form of the square root of 8? 2 square roots of 2. And just do a quick check for me. Due to your location, does that need a negative? Yes, no, sure does. On the left of the x. Got it. Okay. Final answer, adjacent. I just found it for you. Over my hypotenuse. 2 over 3 doesn't simplify, but I'm going to check that. And that is that. So take a glance at your front page of notes. Have we really covered anything new? I feel like it's just always the triangle and the same thing over and over. Any questions on that guy? All right. Hit it. Yes, sir, Noah. But I must, it's what? So secant is the reciprocal of cosine, right? So I wrote cosine and I didn't flip it. I see what you're saying. No, you're right. So if you guys, because I saw some weird looks, I got carried away with my adjacent hypotenuse and then I didn't flip it. Let's back up the truck. Sorry guys, my bad. Now, you gotta rationalize. I'm gonna kick the negative out front. Let's cross this off. How about -3 square roots of 2 over 4? Because you're gonna put your square root of 2 on there, so you're gonna have 2 times 2. How's that? Does that look better? Ooh, running out of room. I got so excited about my cosine up there. Okay. All right, now flip the page. All right, let's see what we got. So, given the trig identity, trying to, remaining trig functions. Great. Man, I love it when they want us to have all 6. That's fun. That's super fun. Now, here's the difference. We've done these. We worked on these yesterday. Obviously, these aren't quite as obvious as the previous problems. The previous ones were very specific. Draw it in quadrant 3, draw it in quadrant 2. They give you some fun-filled little information. We have to use all students take calculus to figure out which quadrant we are drawing this in. So because I know I have to draw a triangle, I just put the kind of on the outsides here, my all students calculus, just to leave myself some room so I have room to put the triangle in there. Now, let's start with our first piece of given info. Cos negative. Ooh, okay, all right. So remember, all students take calculus tells you where the functions are positive. So here's what I'm going to do. Everything's positive in 1, so I know it can't be here because cos is negative. Cos is positive in 4. Well, we have negative. Can't be in there. So I'm down to 2 and 3. All right, well, let's figure it out. So process of elimination, sine less than 0. So of course that means negative. Well, if sine's negative, you can't draw it where? In 2. We got to cross that one off also. So process of elimination, we're down to 3. All right, cosine, of course, you've got your adjacent, hypotenuse. We're going to need the missing side because they want all the trig functions. I'm just going to call it x. So I'm going to do my Pythagorean theorem here. -3 squared, x squared, hypotenuse squared. I don't know why my board's being a pain today, but it is. All right, 9, 49. Let's subtract the 9 off 49. So you'll be at 40. And let's root it. And of course, the square root of 40 simplifies to square root of 40, 4 times 10, 2 square roots of 10. All right, we're on it today. We're on it. And just do a quick check. Does that need a negative? It sure does. Okay, because we were going, of course, down. We're going to sneak it on there. So, given the value, blah, 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 find the remaining trig function. So, it wants them all. But I feel confident for the sake of time, if we do the main 3, you could do cosecant, secant, etc. Plus, you might be running out of room because I'm running out of room too. So, I have cosine. Let's do sine. So, of course, sine opposite hypotenuse. -2 root 10. I'm sneaking it in there. We got cos already. Let's do tan. Bless you. Opposite over adjacent. And of course, my 2 negatives. Let's make it positive. And I don't know about you guys, but I'm really running out of room here. And then, of course, I know you could do the reciprocals and make the cosecant, the secant, the cotan, okay? I'm not going to bore you with doing all that. You can handle it. The key is where to draw the triangle. So here we go. Let's figure out this guy. Come on, board. Okay. So again, I'm just going to do my all students take calculus kind of on the outside here. So I got room to make a triangle. Now, I, of course, don't love that they gave you cotan. I rather have tan. So, of course, tan's just our reciprocal of 5 over 1, so think about 1 over 5. Or really what's most important is the fact that that 1/5 is positive. So I'm like, got it, tan is positive in the all, quadrant 1, tan's positive in the t, quadrant 3. So I've got those 2 potentials. Clearly, we're going to get it down to 1. Sine is less than 0, less than, negative. So that eliminates which quadrant? Yeah. So again, just luck of the draw, they're both in 3. They're not always in 3, just luck of the draw here. Okay, so let's label our triangle. So you know tan's 1 over 5, so opposite, adjacent. And those would both need negatives. That's a -1, a sloppy -1 there. 2 negatives, of course, make it positive, so that's fine. Let's figure out our very lovely hypotenuse with a little Pythagorean theorem. And I'm really running out of room. -1 squared plus -5 squared, c squared. So I'm going to have 1 plus 25, really. So square root of 26. Does the square root of 26 simplify? Nope, so roll it on here. And remember, that's always positive. All right, let's just, do you guys have room to write still? Can I fit like sine and, we got tan, let's write sine and cos. I don't know about you, I'm running out of room. So sine opposite hypotenuse. And then let's just do a little rationalize on it. I need a bigger board. Okay, and then let's do cosine, because we have tan listed up there as 1 over 5, so which is good because I really don't have any more room to write it. Cosine, of course, adjacent over hypotenuse. 6, come on, 6. And then of course you're gonna rationalize it. I'm just gonna scroll it down because I need some space here. So I'm gonna put negative 5 square roots of 26 over 26. So we practiced that. All students take calculus yesterday. So just a little bit more of that when it's not super specific as to where to draw it. So once again though, I've taught you nothing new. Nothing new. Okay, calculator time. Well, we've done these. Again, nothing new. If you use a calculator, evaluate, round to 4 decimal places. Be sure your calculator is in the correct mode. So I think one of the things that happened to us on the quiz, because I had some people get the calculator ones wrong, we're not switching our modes, we're checking our modes. So first, your first one should be in degrees. You do not have a secant button. How do you type that in the calculator? What identity do you use? 1 over cos. So you're going to do 1 over the cos. And I'm going to punch it in just to make, that is supposed to be a very tiny degree symbol here. So let's punch it in. So right away I've got a problem. My mode is in radians. So I always check it because they bounce back and forth here. So mode, let's put it on degrees. Let's get out of that. So then I'm just going to type in 1 divided by the cos. And then I'm going to type in the negative 280. Got it. And it says round to 4 decimal places. I'll let you write it down. You can round it, put it on there. 5.758. What's your last digit? 8. Good rounding, good rounding. All right, next to, I see no degree symbols. We're in radians. So let's switch our mode to radians now. Come on, calculator. Load. Radians. Okay, so type, the B one's super easy. We just type it in right as it appears. There's nothing fancy to do. Cos negative 1.81. Round to 4. And then how are you typing in C when you do not have a cotan button? 1 over tan, okay? So, I'm going to put 1 over tan. I'm going to give you a second to type it in. And let's see what you got. Let's test your calculator skills. Negative. Perfect. Negative 4.838. I forgot the 3. 381. What's your 4th digit? 3 when we round up. I heard conflicting numbers. Okay. So any questions on the calculator? Because those to me are like the easy points on, because there's going to be some of those on the test too. Those are easy points to get. This kind of sorta is maybe the only new thing I have for you today, which we've already kind of done it a little bit. So here's the difference. In the past, we have found these angles, but they've restricted you to only quadrant 1. Now, they want 2 answers. So we are going to be in 2 quadrants. I can look at that square root of 2 and I can tell you right now, what triangle are we on? Which special triangle has square root of 2 on it? 45. I know I'm on the 45, 45, 90. I need to get the 2 answers though in the 2 specific quadrants. So, let's start with the graph. And again, to figure out which 2 specific quadrants I'm going to draw this in, I'm using my all students take calculus. Keeps coming back to that, okay? So I know it's the 45, 45, 90 because of the square root of 2. More importantly, this is for dramatic emphasis, we have positive square root of 2 over 2. So what 2 quadrants is cos positive in? 1 and 4. So I'm going to draw the triangles in 1 and 4. I'm going to start in 1. Now, of course, we knew with the square root of 2, we were on that 45, 45, 90. So I'm just drawing my plain old boring 45, 45, 90. Obviously, when I do the cosine of that triangle, adjacent hypotenuse does rationalize out to square root of 2 over 2. But what we are after on this It wants the angles. It wants the measurements of the angles, not the sides. We know the sides are square root of 2 over 2, so I want to know my angle. Well, of course, my first one's just plain old boring 45 degrees. And due to the directions, it wants the radians too. Do you know 45 in radians off the top of your head? Pi over 4. Or convert it, but that's a common one. We see that a lot. Okay, so that was nice and easy. Now, second one, I gotta get the second answer in 4. Now, here's the thing. We already know we're on the 45, 45, 90. We all know how to label the sides, blah, blah, blah. We care about the angles. I can't say as I really measure and mark all the sides and stuff, because I know it's the 45, 45, 90. I need the angle. Now, clearly, it's not just plain old 45 degrees. We're in a completely different quadrant. You have to measure from 0 over. You are 45 shy of a full circle. So what's your second answer? 315. We'll put it in radians here in a second. Let me ask you one other quick question before we convert it. Does negative 45 degrees, would that be the same thing? Yeah, the only reason I didn't give negative 45, which is easier to list, I'm well aware of it, is because of these darn directions. You have to be between 0 and 360. You can't have a negative answer because of the directions. But negative 45 is the same thing. All right, convert it. What is that in radians? I feel like we're doing a lot of work. If we're good at fractions, we could do it in our heads. Should we do it in our heads? What's a full circle? 2 pi. You're taking off 45, aka a quarter pi. What's 2 pi minus a quarter pi? What's 2 minus 1? 7 pi over 4, 1 3/4 pi. Oh, fractions. Got it. So we've done the first one. We've done that 45. We've done that before. We've kept you in quadrant 1. But now you have to give a second answer because you can be also in a second quadrant. So this is the only kind of new thing I have for you. So let's do another one. All right, so first let's get the graph. All students take calculus. Let's get into it. Nothing fancy here. All students take calculus. It was always, I don't love that they gave you cotan. So I'm going to think about that's over 1. I'm going to write it as tangent and just flip it. So tangent would be negative 1 over root 3. Now, obviously, normally we'd rationalize that, whatever, but I don't even care so much about that because I noticed the 1 and root 3, I like those. 1 and root 3 are on which special triangle? 30, 60, 90. So I know I'm on the 30, 60, 90. I just got to figure out where now, okay? So key, negative. Okay, all right. Process of elimination. Well, I can't draw in the A because everything's positive there. We have negative. And I can't draw in the T because tan is positive over here. We need it negative. So I am down to 2 and 4. So I'm going to draw the triangles in 2 and 4. Because remember, 2 answers. I'm going to start here in 2, and then I'll get the 1 for 4. Now, of course, tangent, opposite, adjacent. Now, due to the location, the root 3 would have the negative. What's your hypotenuse, for the love of math? 2. And more importantly, we already said around the 30, 60, 90. We already knew that. More importantly, what angle is across from 1? 30. So I'm sneaking in a 30. Now, here's the deal. I can't say my answer is 30 degrees because 30 degrees is in which quadrant? 1. We're in 2. You have to measure from 0 over. You are 30 shy of the 180 line. So your answer is 150. Okay, put that also, because of the directions, I want you to give it in radians. Give it to me in radians too. A little converting. Do your pi over 180. It always goes quiet when we have to do fraction work. 5 pi over 6. Perfect. circle this. Okay, now that's the first answer. We got to draw in 4. Now here's the thing. Let's work smarter, not harder, right? We're after the angle. I know the sides of the triangle. I know it's the 30, 60, 90, blah, blah, blah. I don't even like relabel the whole sides. We already figured out the reference angle was 30. That's what I care about. If you want to relabel all the sides, relabel all the sides. You do you. But again, I'm after the angle. Now, clearly the answer is not 30. That's in quadrant 1. You have to measure from 0 around. You are 30 short of the 360 line. So what's your second answer? 330. Which is, got it. So this stuff at the end is maybe the only quote-unquote new part of the day. And I say that kind of sarcastically because I don't know if it really is. But you have to get your 2 answers.